Everybody, today we're going to do section 9.1. 9.1 deals with solving quadratic equations with the square root method. Let's take a look at the worksheet that I sent out a couple of days ago. I'll share that screen with you. And there we are. So what's in red here is how I actually did the problem. So we're going to actually, with the square root method, if you have x squared and there's no x to the first power, you isolate the x squared. In this case, I added 10, and then take plus and minus the square root. Why plus and minus? Because if I square something and it's negative, I can get 10. Or if I square something that's positive, I could get 10. So we take care of that by doing plus and minus. And so when we plus and minus the x squared, squares and square roots cancel, giving us x, and then plus and minus the square root of 10. There's nothing we can do with the square root of 10. There's no perfect square inside the square root of 10. So if we have an equation that has a little bit more to it, it has an x squared, no x to the first, I'm going to think about using the square root method. So in this case, we'll subtract 6 from both sides. That'll give us 18, and then divide both sides by 2. We get x squared equals 9. When x squared equals 9, same idea. We'll plus and minus, square root the x squared, and plus and minus the 9. So squares and square roots cancel off, giving us x. And then the square root of 9 is 3. So plus and minus 3. Sometimes we have a quantity squared, like in C. In fact, many times we do. So what we're going to do is we're going to isolate that quantity squared. In this case, we'll add 9 to both sides. That gives us the quantity x minus 3 squared equals 16. Now, since this is a quantity, that whole thing's a quantity, and it's squared, I can plus and minus square root that whole thing. Just like up here with the x squared, squares and square roots cancel each other off. That'll give us x minus 3. On the other side, when I do plus and minus the square root of 16, I get plus and minus 4. Now that gives us x minus 3 equals plus and minus 4. So to solve this for x, remember we have to isolate the x. We add 3 to both sides, giving us x equals 3 plus or minus 4. And since these are integer numbers, or if they were rational numbers, same idea, we would add and subtract those out. 3 plus 4, that'd be the positive case, gives us 7. And 3 minus 4, the negative case, gives us negative 1. For D is the same idea, except we have to do some division since this 2 is in front of that quantity. So again, we'll isolate the x plus 4 squared in this case. To do that, we'll first subtract 14 from both sides. That gives us negative 7. And then we divide both sides by 2, we get negative 7 over 2. Now, anytime you have a square and you have a negative number, you know there's going to be a complex number or an I someplace along the way. And so when we plus and minus square root both sides, we get the square and square root here canceling, giving us x plus 4. And over here we have plus and minus square root of minus 7 over 2. Now remember, the minus underneath the square root gets pulled out as an I. So that's where this I came from. And a plus and minus I, square root of 7 over 2. Now we can probably simplify that 7 over 2 under the square root before we subtract the 4. So to do that, I'll take the square root of 7 over the square root of 2. Then we'll rationalize the denominator by multiplying top and bottom by the square root of 2. Square root of 2 times square root of 2 down here gives us square root of 4, which is the same thing as 2. That's where the 2 comes from. And then the square root of 7 times the square root of 2 is the square root of 14. There's nothing we can do with that. There's no perfect square in 14. So we'll subtract the 4 now from both sides. We'll get minus 4 plus and minus 14, or square root of 14 over 2i. Notice how that's in that a plus b I form. And that's how we want our complex numbers to be written. For E, we're going to go through the same process. We'll add 7 to both sides. And then we'll divide both sides by minus 1 to get rid of this minus in front of the quantity squared. That gives us the quantity x minus 3 squared equals 16. We'll plus and minus square root both sides. That gives us x minus 3 equals plus and minus the square root of 16, which is plus and minus 4. Add 3 to both sides, and you get 7 and minus 1 again. This basically was like C, except we divided by the minus 1, because it had a negative in front of the quantity squared. And lastly, for F, for this case, there's nothing being added here to the quantity squared, so we'll just divide both sides by minus 3. So that gives us x minus 2, quantity squared equals minus 9. Remember, when you have that quantity squared, or any square equaling a negative, there's going to be an I involved. And in fact, we'll get that I in a couple of minutes. We'll take plus and minus the square root of x minus 2 squared. That gives us x minus 2. That's where that came from. And then plus and minus the square root of minus 9. Remember, the minus gets pulled out as an I, and the square root of 9 is 3. So it's going to be plus and minus 3i. We'll add 2 to both sides, and then we get the a plus bi format. Hopefully this helps. We'll see you soon.